Hi, my name is Tiffany, and this is Lab 3, Black Hole. Introduction. This lab has two parts. Part 1, we analyze the star's motion to determine the mass of the black hole. And Part 2, we use the calculated mass of the black hole from Part 1 to determine the initial velocity of a spaceship so that it can be close enough to the black hole but still be able to leave the system without damage. We're assuming that the net force on the star is only the black hole and that the time between data points is 1 Earth day. And the system is a star, the surroundings is the black hole. So a brief preview of my results. The mass of a black hole is 2.4045 times 10 to the 34. And the ship speed is written here. Okay, some fundamental physics principles used in this lab are perpendicular net force, parallel net force, the position update formula, and the velocity update formula, and then the gravitational force. And hopefully through this lab we can prove or we can demonstrate Newton's second law of momentum, which states that the net force is equal to the change in momentum over the change in time. Part 1, mass of the black hole. So through the GlobeScript model, that that created a unique mass for me. The star's mass is 2.0 e to the 30th, and then delta t is every second of every minute of every hour in a day. And then the initial velocity and the final velocity. And then we have the initial position, final position, and then I just edited this part of the code to get my results. And this is the gravity factor that we used in this lab. Okay, this is the results from part 1. This is what GlobeScript created after running the code. And these are my final results in the left right here. I won't go into more detail. Okay. And then part 2. This is what I edited in GlobeScript. These are the given factors. The ship speed, these are what I got out through trial and error. I've tried many times, but I couldn't get the perfect, obviously I couldn't get the perfect velocity. And then I edited these parts of the code. And then this is what I got as my results. It's the closest I can get to having having it go around the black hole and then leave. So some possible errors. This is only a simulation. It cannot and will not represent reality completely because we're only assuming things. We have the assumptions, and obviously it's not reality. And then there could be more precise velocities. Obviously what I had was not perfect and it couldn't, it's not perfectly what could get the ship closer to the black hole and then leave the system safely without crashing into the moon, for example. So discussion. What does this mean? How is the net force and its parallel perpendicular components different from the rate of change of momentum and its components? So mathematically, these are the same thing, but the net force is more difficult to measure because we need to know every external factor that exerts force on the system, while the rate of momentum, we only need to know the system's change in velocity. And so if we wanted to predict the motion of the entire system, we needed to find all the individual forces acting on each object in the entire system. And then some interactions could be more dominant than others due to the mass of the object in the system. For example, the black hole would be the dominant object in the system containing the Earth, the Moon, and then the black hole. Okay. and thanks for listening.